on the Geodetic Control Technical Working Group for July. Big crowd of people. That's really good. Big topic, of course, and that is understanding, preparing for, and working with the new Idaho State Plane Coordinate System, currently called SPCS 2022, which is a direct byproduct or product of the NATREF, we say, North American Terrestrial Reference Frame of 2022. Now, don't get too nervous. It really hasn't come out in 2022. In fact, even though we're in 2024, it still hasn't come out, but it is scheduled to roll out in 2025, which, you know, is really not that long from right now, especially when we need to prepare for such things. The entire Geodetic Control Technical Working Group agenda for this month is devoted to this topic, and that's where we're going to be spending our time. I'll ask folks to keep their microphones on mute until you have a question. We do have a question and answer session, but I think it might be good in some ways that, because this is rather lengthy presentation, you can put your questions into the chat line. I'll be watching those. You can also unmute yourself if you've got a question right here, right now type of thing, and we'll see if we can take care of that. We might, in some cases, some of the presenters might just ask you to wait a little bit, but we do want to get questions answered. That's a really important part of what we're doing today. So I'm going to kick things off a little bit here to talk about the system, just a little bit of an overview for you. Need to make sure, there we go. The current State Plane Coordinate System consists of 3 zones. That is Eastern, with the FIPS code or numeric code of 1101, Central, that's 1102, and West, 1103. I overlaid the county boundaries on here just as a little bit of a orientation for you to help you visualize those things. Now, all 3 of those current State Plane Coordinate System zones use transverse Mercator, TM, as its projection. They also use NAD, North American datum of 1983, as the underlying datum, with various ellipsoids and realizations being used over time. Let's see. Our first presenter then is going to talk a lot. The majority of this presentation is going to be by Dan Detterman with the National Geodetic Survey. He's going to be talking about the new 9 zones of SPCS 2022 and lots of details regarding those things and the improved precision or low distortion that's going to result from those things. So Dan, are you connected?
I am. Can you hear me?
Yes, I can. Go ahead and just say next or next slide, something like that, as you want to go through it. The floor is yours.
Okay, sounds good. A lot of these I'll probably go through fairly quickly. Anyway, for those of you that don't know me, my name is Dan Detterman. I'm the Northwest Regional Geodetic Advisor for National Geodetic Survey. I've been doing this about 6 years now. Go ahead to the next slide. Northwest region, by the way, is Idaho, Washington, and Oregon. So the NGS's mission is to define, maintain, and provide access to the National Spatial Reference System, or NSRS, to meet our nation's economic, social, and environmental needs. The NSRS is a consistent coordinate system that defines latitude, longitude, height, scale, gravity, orientation, and shoreline throughout the U.S. Next slide, please. So the NSRS provides a consistent coordinates throughout the nation. It provides the positioning framework or foundation for all geospatial products. You see at the bottom layer on the right there is the NSRS as the foundational layer. Next slide. So this is just our NGS homepage. I wanted to point that out. There's a ton of information there. You see on the bottom right, kind of in the middle there, or towards the bottom, new datums. If you click on that, next slide. This is the web page that'll come up, our new datums web page. There's a ton of information here. Can read about our delayed release message, all about the background, what to expect, how to get prepared. All three of our blueprint documents are available there and have been updated. I believe last time was 2021. You can track our progress. And then there's also videos you can watch. You can ask questions. I did want to point out that you subscribe to email notifications. You'll get 1 or 2 emails a month, and it just updates you on what's becoming available, any classes or presentations, anything like that, you'll get notifications. And then also so I wanted to point out that you can click on that Alpha website to get to it. I believe the next one is just our state plane coordinates page. So next slide, please. This is the old state plane coordinate system of 27 and 83. Next slide. And there's the old system, 83. You see your west, central, and east zones for Idaho there. Next slide. And this is the actual state plane coordinate system webpage that will come up. Again, you can go to the Alpha site there in blue, and then this just shows you the current system. Can you go up one, Keith? Okay, go ahead and go down, sorry. So these are the current existing SPCS 83 zones. If you look in Idaho there, you can see a lot of dark blue and even black. So you're looking at over 400 parts per million in the steep mountains there. Next slide. And this compares to the statewide zone for our state plane coordinate system for 2022. And I do have some zoomed in slides later. Next slide, please. This is the distortion for the complete coverage designs layer. And again, I'll have some zoomed in slides of that distortion. Next slide. I believe this is basically the same thing. The first one was at plus or minus 20 parts per million, and this one is 50 parts per million. Next slide. So these are the new SPCS 2022 complete and partial coverage designs. And then there you have your broken up into how much population and cities and area you're covering, and at the different distortion levels. Next slide. So here's our Alpha site. If you look there on the left side, the state plane coordinate system of 2022, if you click on that, that'll bring you to SPCS 2022 Alpha site. Next slide, please. And then here you see everything that is preliminary now, released on the Alpha site. There's a lot of statewide maps there that I've actually put into upcoming slides, but wanted to point out, this is where that you can go in and look at different distortion maps. You can get online interactive maps where you can actually zoom in and out on the different distortion maps at different areas. And there is, I do have a comparison of the transverse Mercator projection compared to the Lambert conformal conic and the oblique Mercator later in the presentation. Next slide, please. So I just wanted to point out also our beta website. And this is where things have been a little more tested than the alpha site. They're still not final, but this is where we'll put things for you to go in and start testing them, look at it. You can, of course, look at things on our alpha site, but that is preliminary. The beta site is where we'll put things available for you to go in and start testing and giving us feedback. I think the alpha site was primarily set up for the manufacturers, the coders, to get the different parameters set up in their software. So that was the main reason for the alpha site. And like I said, the beta is for release and testing and feedback. Next slide, please. So this is your new state plan coordinate system of 2022. Next slide. These are several slides from the Alpha website there that just show different information about state plan coordinate system of 2022. You see they're color coded according to how many layers the state has. Idaho has 2, and there are 28 other states with 2. 10 states have 3, which is the orange color, and then 12 states and 6 territories have just a single layer. Next slide. And then this is the number of zones each state got. And then there's also some that weren't included, such as Puerto Rico, Virgin Islands, and American Samoa. Next slide. So this is just shows the number of farms that were submitted. There were 67 in total from 41 states. Of those, 36 were requests and 31 were proposals. Next slide. This is the number of zones that were designed by the states or the stakeholders. So any of the non-colored states basically had their zones designed by NGS, which Idaho and Washington both had NGS design all of their zones. Oregon actually already had low distortion projections for all of their state. Next slide. So these are just, this is a distortion map across the country showing the statewide zones. You'll see there, and I'll have a blow up of Idaho in particular. Next slide. And this is the complete coverage designs by NGS and the states. Next slide. And these are the linear distortion for complete and partial coverage designs. Again, I believe, so this one just shows the percentage of the population, percentage of cities in the area covered by those distortion levels on the left there, plus minus 20, 50, 100, and 400. And then you also get your minimum, maximum range and mean there. Again, color coded according to distortion at the topographic surface as opposed to the ellipsoidal surface, which is how the projections were designed for SPCS 83. Next slide. So this is a distortion map of your statewide layer zoomed in. You can see basically right there where it's plus or minus 50 in the green is where that projection is basically hitting that topographic surface, and that's therefore you're getting the least distortion in those locations. Next slide. So this is your multi-zone layer for the state with the 9 different zones. This one in particular is all transverse Mercator projections other than the east-north zone, which is Lambert conformal conic. And unfortunately, I don't have a distortion map for that east-north zone in the transverse Mercator projection for comparison, but I do have the west-south and the central-south zones to compare. And we'll do that here in these next slides. Next slide, please, Keith. So this is the same map, just with the oblique Mercator for the west-south zone and the Lambert conformal conic for the central-south zone. If you want to go up and then back again, just to compare and look at that WS and CS zones, you can see a little bit of the difference. And I point that out again in later slides. So you can go ahead to the next one, Keith. There you go. So this one I just zoomed in a bit in the same area for the transverse Mercator, and then the next slide, Keith, will show the oblique Mercator and the Lambert conformal conic. And again, if you want to toggle back and forth a couple times just to show folks the improvement from the transverse Mercator to the new projections that really improve the linear distortion. And this is again the comparison. This one I actually was able to get both of them on one slide. It seems to be a lot easier to compare them side by side. Unfortunately, some of the other ones just I wasn't able to get it very clear. So again, this is central south zone comparing the Lambert conformal conic on the left to the transverse Mercator projection on the right. Next slide. Again, this is just zoomed in on the southern half of the west south and the central south zones, both of these transverse Mercator projections. Next slide, Keith. And then same area, west south zone, oblique Mercator, central south zone, Lambert conformal conic. And again, you might want to toggle back and forth a couple times just to show the improvement. Not a whole lot there, but you really do see it in the mountainous areas, and that's really where you get your biggest distortion, is when you move vertically away from that projection as opposed to horizontally. You still get linear distortion, but it's much more exaggerated as you move away vertically. Next slide, Keith. So again, just comparing, this is the north. Yes. Did you have a question, Mark?
Might be off, sir.
You're kind of breaking up. Am I breaking up?
No, you sound good, Dan. If someone has a question, maybe having problems with their microphone, just feel free to pop it into the chat line. We'll get to it as soon as we can.
Yeah. Thanks, Keith. You can go into the next slide. One more, unless you wanted to compare those two. There you go. So, and then here's, again, just a little more zoomed in on the particular west-south zone. There's transverse Mercator. Next slide. oblique markator. Toggle back and forth. And there you can see the improvement. Next slide. This is the north part of that zone again. Next slide. This is the transverse markator. Next slide is the oblique markator. So again, you do see improvement in the mountainous areas there. And you really actually see the valleys open up and turn green, if you notice, which is good because that's where most of the population lives. So getting that linear distortion down to the less level in those areas is definitely an improvement, because that's, in most cases, that's where you're working. Next slide, Keith. So this is the particulars of the parameters for each zone. You can see, and I don't know that I can even read a lot of that, but basically it breaks down each zone. Telling you what your projection axis, latitude, longitude, axis scale, false northing, false eastings, and then your performance statistics on the right. Just a lot more information, and that is also available on the Alpha webpage. Next slide, Keith, which is just another more parameters. This also gives you the particulars of where the test point was and the test projected coordinates and statistics. Next slide. Again, all of those are available on our Alpha website. So one other thing I definitely want to mention is, to get prepared, is really keeping track of all that metadata. You want to require complete metadata from any contractors and record complete metadata yourselves. You want to preserve all of your original observations and inventory your existing data and metadata, and make sure you can basically record anything that you can. And then this just shows a complete nomenclature for the horizontal and vertical datums. Of course, the current horizontal datum is NAD 83. Current realization or adjustment is 2011. And the reference epoch is epoch 2010.00. For the vertical datum, the current NSRS vertical datum is NAVD 88. The reference ellipsoid is GRS 80, and then the geoid model is geoid 18. Next slide, please. So again, to prepare, just know the epoch of your data and data sets. Consider how you want to track this. Do you want full to the second timestamp for every feature? With modern survey equipment, that is possible. However, you can label a year for each data set. That's easy to add to your workflows, data sets, databases, and folders. And or do you want something in between that works for your needs? We don't tell you how to do it, just please do it. Next slide, please. Next slide, sorry. And again, this is just how you can subscribe to our email. You'll get 1 or 2 messages a month. It includes NGS news, modernization newsletters. Tells you anything coming up with our webinar series, any training available, and this is a dated slide because it still says GPS on benchmarks. However, I do want to mention that if you do want to get a mark that you haven't gotten data on in a long time, you can still do a shared shared position in Opus, and when the next time we would do a reference epic, that would also get coordinates in the new datums. Next slide. I think that's it. Thank you. Sorry, I took a little more time than wanted.
No, this is very good. Thank you very much for doing this, Dan. We had
Absolutely.
one question come in. I think I answered it, but maybe you could answer it a little bit more. And that is a question is, what is distortion, parts per million? My answer was, if you measure 1 million feet, if your distortion is 1 ppm and you measure 1 million feet, you'll be off by 1 foot in a million feet measured. Did you want to go into more detail on that or correct that?
No, that is absolutely correct. And the only thing I would add is that I believe, I'm actually not even positive about this, but that's within 1 standard deviation. So
Yeah.
95% confidence level.
Right. Yeah. And what you saw there, folks, as we were going through those slides, and of course you can access all those from the Alpha site. There's an experience builder site that NGS has. What you're looking for is green. Green is where we want to be. That is very, very low distortion. That's the plus or minus 50 parts per million. And what we want to do is stay away from the black. And so you probably saw the tremendous shift away from the dark blues and blacks, where we were in some cases 400 parts per million across the state of Idaho. And we're not seeing I don't think we're hardly seeing any black anymore. Blues and greens, kind of what we're seeing, and minimizing anything away from the green colors, which of course is that plus or minus 50 parts per million. Kara says, I understand what the acronym means, parts per million, but the actual question I had was already answered as you went through the slides. Oh, okay. Very, very good. I guess I didn't have to read that out loud, but I wanted everyone else to see it. I don't know if everyone's watching the chat line or not. So thank you very much, Dan. If you can stick around, or maybe some more follow-up questions from folks after we finish all of the presentations. And I'd like to turn the floor over.
Sure.
To Stuart now. Stuart Ward is going to talk. Stuart is the chair of this committee. He's also a PLS, licensed PLS here in the state of Idaho, does a tremendous amount of work for the state of Idaho, the multi-state control point database. And so here we are. We're getting ready for the new SPCS 2022. It's going to roll out, you know, in less than a year. I bet you we'll have it out there available to us. Okay, well, how now do we use this thing? So Stuart's going to talk about how to use this new system in Trimble Business Center. It's going to be very similar to how you might do it in Leica as well. But go ahead and you got the floor, Stuart.
Okay, thanks, Keith. You make it sound like I have insider data or something to show how this is going to work, but basically what I'm going to show, because the datums aren't available, is how to transfer, which the steps are very similar, but how to transfer right now from NAD83 state plane to a UTM zone, which the data transformation will work basically the same in Trimble Business Center. So go to the next slide, Keith. So this is just a point in Trimble Business Center, and you can see, click it again, Keith, for me. Right there, ground coordinates, Idaho East, Geoid 12B, Northings, Eastings, and down you can see that it's global coordinates are NAD83 2011, EPIC 2010. Next slide. So in Trimble Business Center, you would click on your project settings. Click it one more time, Keith. And you would go to your coordinate system there, and then click down on that box that says change. Next. and it'll bring up this screen, and you're going to click coordinate system and zone. And like I said, in this case, we're going to go UTM. Click one more time. So UTM, and we're in 12 North Zone over here in Eastern Idaho. Next. Click next. Yeah, sorry. And then it's going to bring up this one where it's going to ask you your horizontal datum, and it's got this whole list, but we want to scroll all the way down to the bottom. That's WGS 84. Next. And then you click the next button. Click again, Keith. And then you'll click or select your geoid if you want it, and you'll scroll down to whatever geoid, and then hit finish. And then it's going to bring you back to this screen, and you can see that the coordinate system, the summary screen there, has changed to worldwide UTM 12 North, WGS 84, geoid 12 or geoid 18, sorry. And then you hit OK, next, and next. And then you can see right there that those grid coordinates have changed to UTM coordinates, but the global coordinate has not changed. Between the very first slide and this slide, the global coordinate down at the bottom of that table has not changed at all, just the northern, easting, and elevation there. So the Trimble people are going to figure all this out for us, which is nice that we don't have to do it. And so the transferring datums from the old to the new and vice versa is going to be very similar steps on this one to this. And so I don't think there's a whole lot that we need to worry about from that standpoint. Just making sure, like Dan said, that we know what datum and epic that we're using, so we can go back and forth and make sure we pick the right ones. So I think that was my last slide, Keith. Yeah.
Yeah, well, thank you very much, Stuart. Do we have any users out there who've connected who are using something like Trimble Business Center, or perhaps using Leica or TopCon systems? You could digitally raise your hand or something like that. Okay, maybe not. Well, let's go ahead and let's talk about, there we go. Adam is one of those users who could use that information. One of the things that both Dan and Stuart both mentioned is, of course, to use the most current datum and the most current realization of that datum, which in 2025 most likely will be the full SPCS system, part of the new National Spatial Reference System. But the other thing, don't forget to add that information to your metadata documentation. Otherwise, folks may not really know what you're using. Oh, it was, you know, SPCS 2022 for Idaho East or something like that, but then you're not really sure 6 months, a year from now, what realization and exactly what version of that was used. So we need to make sure we do document that. And I know ARC helps out quite a bit, carries along that sort of stuff for us with the PRJ or projection files, but we should also be sure, myself included, to make sure that we document that in our geospatial metadata. I want to talk to you about how to do very, very similar things with ArcGIS Pro. So I'm going to go ahead and step through a similar presentation that, just like what Stuart just did. I also do not have access to the final SPCS 2022 because it's not absolutely final yet. But let's talk about how we do this. ARC will call it doing a projection, right? So we have most of our zones, by the way, in the new state plane coordinate system, use transverse Mercator as the underlying projection. Some zones you noticed with Dan's presentation use Lambert conformal conic, that's the LCC, or the Hotine oblique Mercator, that is the OM that you saw on those alpha maps. That's different. That is definitely different for the state of Idaho. We're so used to seeing TM everywhere, but rest a little bit assured at least, because all of those datums that we're using, whether it's transverse Mercator, Lambert conformal conic, or the oblique Mercator, all of those datums are conformal. In other words, they are designed to preserve the property of shape. And by the way, I think you also know that none preserve the property of area because they're not equal area projections. There will be that distortion. But conformal projections like TM, LCC, and OM are very, very similar in this respect, that they preserve the property of shape for us. So they're really not that terribly different. Projecting and transforming our spatial data in ArcGIS Pro, obviously we use the project geoprocessing tool, or we might be using the project raster geoprocessing tool, dependent upon if we are projecting vector data or raster data. And a project allows us to change the projection. In other words, the projection of transverse Mercator changing to Lambert conformal conic. This same tool, the project tool, also allows us to transform the data, and we need to transform the data whenever we're changing the datum, the underlying datum. You might recall from your days in college that a spatial reference system is composed of 3 pieces. First of all, very simply, the way that you are measuring, so whether you're measuring things in feet or meters or variations of thereof, but it also is the projection that gets you out of the round world of a globe, and it also is the datum, which is your Earth model, right? So we need to project, and sometimes we need to transform. So here's an example. What we're going to do is, I am purposely really changing things up. I'm going to project Idaho County's vector polygon feature class from its current system, which is Idaho Transverse Mercator, NAD 83. That's our current statewide system. And I'm going to project it into a cylindrical equal area. That's the WKID 6933 if you're interested. By doing that, I also need to change the underlying datum from NAD 83 to the WGS 84 datum and geoid. So I have selected all that stuff here. This is the input. This is my output feature class that's going to be written to my default geodatabase. This here defines the output spatial reference system. And this is the required, because we're doing a transformation, we're changing datums, we have to tell ARC what transformation method to use. And normally, it's going to figure that out for you. It'll make a recommendation for you that whenever you're going from NAD 83 to WGS 84, you should use this system right over here. And that's what it's going to do. Okay, so that's cool. We go ahead and click OK. I actually did this transformation and full projection. And when it got finished, I couldn't tell the difference between the 2 layers that were done. It really does a good job. So as long as those projection files are defined properly and well written, then there's no big secret about how it's going to work, or nothing magical about the new system that's going to come out. Yes, there's quite a bit of math involved, but the software, whether it's ArcGIS Pro or Trimble Business Center, will take care of that for you. I'm not alluding to or suggesting that people need to allow everything to become black box. Just click it and it'll do it. We should know what we're doing. We need to know what we're doing as part of our profession. But at the same time, we're not going to have to take out a pad of paper and a pencil and and do a bunch of math by hand. We need to know what we're doing and how to do it properly. So that is the deal. That is what we're talking about. Welcome all of you to our Geodetic Control Technical Working Group. This is the type of stuff we deal with all the time. Big topic, of course, today, and I'll open the floor for any questions that folks may have.